Imagine just for a second that you're a digital detective. You've just been handed an absolutely monumental case. According to a recent Gallup poll, 114 million Americans believe the U.S. healthcare system is failing them. That is a staggering amount of frustration, anxiety, and concern. But how do you actually measure that? I mean, how do you capture the exact real-time feelings of 114 million people spread across a massive country? You obviously can't interview all of them. That sheer scale, 114 million people, represents a huge chunk of the U.S. population interacting with complex systems like Medicaid. So, to solve the mystery of what exactly is driving this public outrage on any given day, researchers had to get pretty creative. They needed a way to listen in, legally and ethically, to the unfiltered conversations of the public. They basically needed a real-world wiretap. And they found a perfect one in Twitter. Welcome to The Explainer. Today, we're diving into a genuinely fascinating machine learning framework developed by researchers to analyze Twitter discourse on the U.S. healthcare industry. This framework acts exactly like a digital investigator, translating millions of chaotic, noisy tweets into the exact real-world events that are driving public sentiment. Here's our detective playbook for today. 1. The healthcare perception problem. 2. Gathering the digital clues. 3. Spotting the sentiment spikes. 4. Deciphering the hidden patterns. And 5. Solving the sentiment mystery. Step 1. The healthcare perception problem, finding the pulse. Let's quickly establish why traditional methods of taking that pulse just aren't cutting it anymore. Here's the thing. Traditional surveys are fundamentally flawed when it comes to the sheer speed of the modern world. They're incredibly slow, they're expensive to run, and honestly, they often miss the actual real-time sentiments of the public. By the time a survey is even published, the public has completely moved on. Twitter discourse, on the other hand, that provides massive scale and immediate reactions. Whether people are tweeting about affordable healthcare access, skyrocketing prescription costs, or delays in care, social media gives researchers an unfiltered, real-time window straight into the public's mind. Which brings us to step 2, gathering the digital clues, or building the net. Because having access to Twitter is one thing, but actually capturing the right data is a whole different ballgame. To collect all this raw evidence, the researchers didn't actually use Twitter's official API, which has a lot of limits. Instead, they built a custom net using an open-source tool called SnapScrape. This allowed them to legally and really efficiently mine over 762,000 tweets between January 2021 and December 2022, focusing specifically on the keyword Medicaid and the hashtag Medicaid. That is an absolute mountain of digital evidence. Now, to scrub this raw evidence clean, they built a meticulous pre-processing pipeline. Raw tweets are messy, right? They're full of slang, weird links, and random characters. So this pipeline systematically removes URLs, handles emojis by literally converting them into text, strips away non-alphanumeric characters, detects and translates non-English languages, removes common stop words like and or the, and finally lemmatizes the text, which is really just a fancy way of saying it breaks words down to their absolute root form. Let's look at how this works in practice. We start with a pretty chaotic Spanish tweet, complete with an angry red emoji. Through the pipeline, it gets translated to English. That emoji becomes the text enraged face. And by the end of the lemmatization stage, it's stripped down to its absolute core, essential English keywords. So we get healthcare cost, expensive, United States, enraged face. What you're left with is a perfectly clean string of data that a machine learning algorithm can easily digest. Step 3, spotting the sentiment spikes. We're looking for the anomaly. With our evidence clean and organized, our digital detective needs to find the plot twist. To spot these anomalies, researchers used a tool called Vader. Think of Vader as a highly advanced digital mood ring specifically trained on social media language. It reads a clean tweet and assigns it a score from -1 to +1. So, for instance, a tweet complaining about nonsense emergency care gets a -1, but a tweet saying they receive good care gets a +1. The algorithm takes this and applies it to all 760,000 tweets. Once every single tweet is scored, the overall sentiment gets plotted over time by taking the positive sentiment and subtracting the negative sentiment for each day. And when you look at that timeline, you start to see these sudden, huge jumps. Those are the anomalies. A spike is officially triggered when the overall sentiment jumps by a massive threshold of more than 500 points in a single day. When that happens, our digital detective knows something major just occurred in the real world to make Twitter explode. Step 4. Deciphering the hidden patterns. We have our spikes. Now we need to step into the machine learning interrogation room to find out exactly why they happened. To figure out the optimal number of groups or clusters to organize thousands of tweets into, researchers use something called the elbow method. You basically look for the point of diminishing returns. It literally looks like the elbow of a line graph. Finding that sweet spot tells the system that, mathematically speaking, grouping the evidence into that specific number of clusters will give us the clearest understanding of the data without totally overcomplicating it. Inside those clusters, the algorithm goes to work deciphering the themes. It calculates something known as TF-IDF, which is a method that basically weighs how important specific words are during the spike compared to just normal, everyday tweeting. It groups words by how often they show up together, uses a cool statistical technique called Gibbs sampling to guess which underlying topic each word belongs to, and then rearranges those keywords strictly by importance. It is quite literally compiling a master list of the most critical clues from the scene of the sentiment spike. And finally, step 5. Solving the sentiment mystery, cracking the case. We have our clues, now we need to track down our culprit. The algorithm has this one final, totally brilliant trick up its sleeve. It takes that reordered list of important keywords we just talked about, and it plugs them straight into a Google search. But here is the genius part. It actually restricts the search to the day before the Twitter spike, operating on the incredibly sound logic that the news event caused the reaction, not the other way around. Then it runs a loop. It searches, drops the weakest keyword, and searches again. It repeats this up to 6 times, comparing the search results to the Twitter keywords using a mathematical association score. Check out how this progresses for a massive sentiment spike that happened on July 31st, 2021. On iteration 0, searching a huge, clunky string of words just yielded some random PDF document. But as the algorithm iteratively stripped away the noise, dropping words like socialist and programs, the association score kept going up. By iteration 5, the highest association score pointed directly to news articles titled, "Medicare and Medicaid turned 56 today. That's not exactly cause for celebration." Boom! The algorithm successfully caught the exact real-world culprit driving the healthcare outrage on Twitter that day. The framework works. The power of this methodology is just absolutely incredible. By combining customized data scraping, rigorous text cleaning, Vader sentiment scoring, and machine learning clustering, researchers can now impartially map the sheer chaos of social media directly to real-world events. It gives policymakers and organizations an unprecedented, data-driven window into the public's actual needs and frustrations. But I want to leave you with this final provocative thought. If an algorithm can flawlessly trace the root cause of healthcare outrage from a sea of 760,000 chaotic tweets, what other public mysteries could this framework solve tomorrow? Thank you for joining me on this explainer, and keep your curiosity alive.